Here's an explanation for the answer to final exam question number 21 in Electronics Demystified, 2nd edition. If you have the printed book, please see page 421. The question reads, in an AC circuit, resistance and reactance combine mathematically to give us what? And then we're given 4 different choices: susceptance, impedance, conductance, admittance, or permeability. Well, the correct answer is B, impedance. The previous 2 questions actually deal with this very situation, and figure exam-3, which I have reproduced here, shows a rendition of how mathematically and geometrically this works. Resistance we can plot on the horizontal axis of a graph going towards the right, only towards the right, because resistance is never negative. That's what R stands for, is resistance. Real number values. The reactance we plot at a right angle to that on a vertical axis. Jx, x standing for reactance, and J standing for the J operator, which is the square root of -1, making all of these quantities imaginary numbers. So resistance, R, and reactance, Jx, combine mathematically to give us impedance. And these 2 things you see here are complex impedance vectors. Vector P looks like about 7 ohms of resistance plus J 3.5 ohms of inductive reactance. Positive reactances are inductive. The vector Q looks like about 3.5 ohms of resistance and minus J7 as the reactance, which would be minus J7 ohms of capacitive reactance. So mathematically we would combine this vector P, the number quantities here, we would combine to get roughly 7 plus J 3.5, and Q we would combine to get roughly 3.5 minus J7. So that's how that works, and we get impedance when we combine those 2 quantities mathematically, and we can graph them. They require 2 dimensions in order to be rendered properly. You can't render impedance in its full glory in only 1 dimension. You need 2 dimensions. You need the resistance dimension and you need the reactance dimension. Again, the correct choice is B.